the past president of MERALCO.
Stop na. Wait lang, pakita lang namin isa-isa.
Ulitin mo kaya?
Ulit.
Parang yung ano, habang may kasi tahimik eh.
We will know how electricity is produced. Miss Perry Leonida Gamboa Quinola will show us how. When you pedal and rotate the magnet, the wires you see cut the magnetic lines of force. This creates electricity and causes that electric current to run through the wires, lightening the bulb. Look at Mrs. Generators use this principle. You can use your feet, steam, natural gas, atomic energy, wind, and other forces to create the rotation. The hydroelectricity generator, the next tool used as waterfall. Look at Miss Quinola. As she rotates the paddle, look at the wire. Look at the bulb here, which is lightened. Okay?
This exhibit stimulates steam expansion inside the casing of the steam turbine. The mist represents pressurized steam. When you push the button, mist comes out of a hole and passes through the turbine. Turbine blades. The turbine blades and shaft rotate. This is the turbine blade and shaft rotate. The shaft is directly connected to the generator, wherein small permanent magnets are attached to the shaft. As the shaft with the magnets rotates, current is induced in the coils of wire. This produces electricity that lights up the LEDs, lightning emitting diodes. In the miniature building, this is the building. The induced current in the coils of wire is due to a phenomenon called electromagnetic induction, which is the basis for the design of all types of generators. This exhibit demonstrates that the energy of falling water can generate electricity. As I press this law, water in the reservoir behind the dam has potential energy. As water from the reservoir is released, its potential energy is converted to kinetic energy. This energy makes the turbine blades and the shaft rotates, the continuous rotation of the shaft transforms the potential and kinetic energy of the water into mechanical energy. Since the generator is directly connected to the shaft of the turbine blade, mechanical energy is converted to electrical energy. This energy lights up the LED or the light-emitting diode. In a hydropower plant, a dam is built to store river water in a reservoir. Water in the reservoir is maintained at a constant level but is released to meet changing electricity needs. Power lines carry electricity from the hydropower plant to homes, schools, and business establishments. This exhibit shows how wind produces electricity. Cramming the blower fan generates air, enough air to move the turbine blade. The turbine is connected to the generator by means of a shaft. Inside the generator are magnets attached to the shaft. As the shaft rotates, electric current is induced in the coil of wire, making the LED light-emitting diode light up. As you can see, the handkerchief holding by Miss Rita Francisco was blowing. The induced current in the coil of wire is due to a phenomenon called electromagnetic induction, which is the basis for the design of all types of generators. Is tidal power. The hand wheel is connected to the belt pulley and back of the water container. The pulley rotates a bigger wheel. From a fixed point within the bigger wheel, a connecting rod fits the steel bar with the ball bearing of both ends. This very freely moves up and down and standing support rods. At the back of the wheel is turned, the bar, which is moves up and down, lands the rectangular block into the water, causing some water to displace. The force created by the changing water levels causes the blade and the shaft to rotate. The shaft has permanent magnets and moves near the coil of wire. As you can see, this lighthouse is being lighted through tidal power. Wow, there are many high-tech things in MERALCO. Tap to click. I hope this is touchscreen. Wait, cool. About electricity. Ching.
Another one.
Components of an electric generating transmission and distribution system. Geothermal energy. The role of transformer and other key line equipment meters. Incandescent bulb, fluorescent bulb. How does the light bulb work? In regular light bulb, an electric current flows through a double spiral coil of thin tungsten wires. As the charges in the current flow through the tungsten filament, they transfer energy to the different atoms through collision. The electron gives up energy to the filament, which increases the temperature. Another one. How an electric motor works. An electric motor works using electromagnetism. It has a coiled-up wire inside that sits between the poles of a magnet. When the current flows through the coils, an electric field is produced. This makes the rotor spin around. And the last one, life of Thomas Alva Edison. Thomas Alva Edison was born on February 11, 1847 in Milan, Ohio, and was raised in Port Huron, Michigan. He was the seventh and last child of Samuel and Nancy Edison. Edison had a very little formal education as a child, attending school only for a few months. He was taught reading, writing, and arithmetic by his mother, but was always a very curious child and taught himself how much by reading on his own. This belief in self-improvement remained throughout his life.
Goodbye.